Alright, and hello. Alright, so what we're going to do today is we're going to talk about the different properties. Sorry, I'm just going to write this down. Properties of multiplication. So, mind my terrible writing. But today is all about properties of multiplication. And what that means is that there are specific types of ways that we can kind of shortcut or, figure out how to multiply with maybe learning these little tips of the trade so that it makes it a little easier when we do multiply. So hopefully by the end of this lesson, you will want to be less like this guy over here and you'll be more happy when you are doing your homework. So let's go ahead and get started. All right, so we're going to start with grouping. We'll start with our first property, and our first property does deal with grouping. So I'm going to refer to grouping a lot. So we're going to talk about it first. So we remember what we were doing with grouping and multiplication. So when we multiply with grouping, so let's say we have a problem such as 3 times 5, we can group this by doing 3 groups of 5 in them. We remember this, right? So we have 1, 2, and 3 little cookies that have no chocolate chips on it, and we're going to put 5 right here, 5 little chocolate chips. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oopsie, that one wasn't very good. 1, 2, 3, 4, 5. So we have our 5 little chocolate chips on our little cookie, and when we add them all up, they should equal 15. So that's what the grouping method was. So we talked about that already. So we're just going to get this out. So what this property deals with is we can try to group. So when we are confronted with a problem such as 4 times 0. Well, we could make 4 groups. We could make 1, 2, 3, 4 little cookies that have no chocolate chips on them. And if we try to put an amount of chocolate chips, well, we can't do that because there's 0 of them. So each cookie has nothing on it. So 4 times 0 is 0. So this method is called the zero product property. And what that means is that any number multiplied by the integer 0 is 0. So if we were to have even like 1,000 billion million whatever times the number 0, because you can't group 0 into however much this is, it'll still be 0. Alright, so our next property of multiplication deals with somewhat of the same rule, except it's a little different. So, again, when we are grouping things, so we're going to go back to this grouping method. Let's say we get a problem that's like 8 times 1. Well, if we know our multiplication table, this is pretty simple because we always know that the first number in the multiplication table is always going to be the number we start with, right? So we know it's 8. But if we were to group this, we would have 8 groups, so 1, 2, 3, 4, 5, 6, 7, 8. 8 cookies with one single chocolate chip in each cookie. So if we were to add these up, these would equal 8. So this property, which we're giving a name to now, is called the ones product property. And essentially what this is that any number, so any integer multiplied by the number 1 will give the same number at the end. So it won't give 1, but it'll give the same number. So let's say we have 10 times 1, or 5 times 1, or 7 times 1. Well, they're all going to equal that same A, so it'll still be 10, it'll still be 5, and it'll still be 7. So the next one we're going to talk about is the one where we're kind of getting into the nitty-gritty, and it's going to be our main focus when we're talking about multiplication and addition. And we've kind of already seen this before when we were using our addition properties. So this commutative property means to commute. So when you're commuting to school, or when I'm commuting home, I am going from one place to another. But the place doesn't change. It's not moving around. So what this means is, let's say we have a problem. Let's say we have, so in addition, we talked about this already, if we had 4 plus 4, ooh, that's not a good example. Let's get a slightly better example than that. So let's say we had the number 3 plus 2. Well, we remember that 3 plus 2 is 5. So if we were to flip this around, if we were to do 2 plus 3, you would still get 5, because even though we're flipping the numbers, the outcome and solution does not change. So essentially, this is the same when we are referring to multiplication. So when we are multiplying, ooh, that's bad. Okay, but you get what I mean. When we're multiplying, we are essentially doing the same thing. So if we were to have a number such as 10 times 5, we can, so 10 times 5, 10 groups, 5 in each group. So if we have 10 cookies and we put 5 sprinkles on each cookie, we're going to end up with a total of 50 sprinkles on that cookie. So if we have 5 times 10, well, this is a little easier to group, isn't it? So if we have our 5 groups of 10 in each, I mean, we could do that right now if we really wanted to. So we have 1, 2, 3, 4. We're going to lay this cookie over here on the 5. Well, we can put our little cookies and sprinkles in each group, and we're still going to get 50 as our outcome. So that's the point of the commutative property. So the commutative property is just saying, hey, I've got my 5 here. Oopsie, I'm sorry. I've got my 5 here, and I have my 3. But what if we were to do 3 times 5? Well, we're still going to get that integer of 15 at the end. So it doesn't matter how we do it. If we're moving it around, it'll still be the same. So the thing is, with this property, it doesn't apply to everything. So we know it applies to addition, we know it applies to multiplication, but you're probably thinking, well, Ms. Martina, does it apply to division and subtraction? Well, no. When you are doing something like that, you're getting a different outcome. So let's say we have 10 divided by 5. Well, 10 divided by 5 is 2. But if we do 5 divided by 10, we don't actually get 2, we get 1/2. So we're having a different solution at the end of this that is clearly different when we flip it. So we're getting something different. With the commutative property of multiplication and addition, we can still flip these two integers and we will get the same outcome. Alright, so of course you're probably already thinking, is this really important, and why is this important to us? And there's actually pretty much 3 reasons that I think learning these properties are going to be important. So number 1, you're going to need these little guys in algebra. Algebra is really important. Maybe that's a bad A, but you get what I mean. Algebra is really important for these types of tricks of the trade. So when we start moving up into those higher maths, you're going to need to remember that the zero product property exists, and that the ones product property exists, and that commutative property is going to make your life for solving for a variable you don't even know yet. It's just going to make it easier. So the second one is thinking about it in context. And what that means is just kind of understanding that these are simple ways for us to understand these problems. So instead of, having to go back to your little chart and realizing, well, okay, 7 times 0 is 0, you're already going to know that. You won't have to deal with an array, you won't have to deal with grouping. You'll already kind of have this automatically programmed. And then finally, the third is using this in the real world. So math is important in the real world, and whether you think you're going to use it later or not, really understanding these properties is going to help you when you're doing maybe quick multiplication at the store or trying to figure out a tip at a restaurant. So it's just using these things in context and really realizing that these are actually really valuable practices, and that you're actually going to learn stuff like this later on. Alrighty, so to recap, we're just going to recap what we learned. So we learned about the zero product property, and the zero product property dealt with any integer that was multiplied by the number by zero would still yield our zero. So we would have our integer, so like let's say we had 7 times 0, it's going to equal 0 no matter what. Even if we have a huge number, we multiply it by 0, it will always be 0. So we've learned that. Our ones product property dealt with somewhat of the same idea, that it's a universal rule and that anything times the number 1, so we could even do it 1 times, make my pen a little bit thicker here, 1 times the number 15 will still give us 15, and that is because we're multiplying that 1 times itself. So if we were to group 15 different chocolate chips, we're only going to ever be able to fit one of them. Or if we just had one group of 15, we're only going to have 15. Alright, and then finally the commutative property deals with the fact that we can flip a multiplication number or a multiplication problem just like we can flip an addition problem. So if we were to have 3 plus 5, we're still going to be able to flip it to 5 plus 3 and still get 8 each time. And if we were to have 3 times 5, we were still able to flip it to 5 times 3, and because they are grouping 3 groups of 5 or 5 groups of 3, we're still going to have 15. Yeah, okay. So that is the basis of what we've learned today. So if we have any questions, please direct them towards me. Don't hesitate if you still don't understand what's going on in this really complicated area of math. It's okay to have questions. It's definitely okay to not get the whole thing yet, because I really want you to kind of get these problems in concretely later on, because you're going to need them for when you start moving into algebra, and it just kind of builds upon itself. So if we're not getting these at the moment, so if we're not understanding these properties, it's really important that you come and give me a holler and you tell me if you need any extra help. So, of course, I guess you're wondering what this picture means up here, and actually, if you can't see it, it says calc you later, and that just means see you later, a nerd. So calculator, I will see you in class. Hopefully bring up any questions. If not, have a wonderful rest of your day.